Sometimes what happens is that as a coefficient of x, you're giving some sort of a multiple of pi. In this case, we've got half a pi put there. The purpose of doing this is to ensure that your values such as intercepts, maximum and minimum points all happen at integer values. That allows us to model things in the real world. So it allows us to model hours or heights or lengths or anything really, because if it's not measured in because we don't measure things in multiples of pi, like we don't look at things that are 3.14 meters. We look at, in the real world, we measure with natural numbers. So that's what we're dealing with here now. For this, we've got function notation. So f between 0 and 8. So that's our domain 0 to 8. For all real numbers, f of x is a function of cos of pi onto x. Now, we don't have an amplitude, so we don't have anything in front, so our amplitude is 1. We don't have anything being added or subtracted, so we're just going to stay. So 0 is our equilibrium or our mean. So basically, let's put in our amplitude is 1, and now for a period, t equals 2 pi over n. In this case, it is 2 pi over pi on 2, so we can rewrite that as 2 pi over 1 divided by pi over 2. And if we're dividing two fractions, we have 2 pi over 1 times 2 over pi. So then we've got 4 pi over pi. Pi's will cancel. So we have a period of 4. So based on that, it's a cos graph, so it's going to start at 1. Now we're going to sketch it between 0 and 8. So we're going to go through and we'll do one cycle, and then we'll go through and do another. So this is at 4, and this here is at 8. And then we're starting at 0. It goes up to 1 and down to negative 1. So, let's give you an idea of if we're going to multiply pi, then we're going to deal with whole numbers, or rather than values of pi along the x-axis, the only numbers that we are more familiar with. And also just to give you an idea of how to do this with formal function mapping notation.